Put your hand up if you're ready to run some modeling experiments. Well, you can't see me, but my hand is up in the air. Let's get started. You might have already tried this out yourself, and if you have, I applaud you. Let's create experiments and set up training code. So we've prepared all of the pieces of the puzzle. We've got a function to save our results to file, and now we've got different data sets, different data loaders, and different feature extractor models to run our series of modeling experiments. We've got 10% training data, we've got 20% training data, we've got EfficientNet B0 and EfficientNet B2 feature extractor creation functions, and we can set up the number of epochs by passing them to our train function from engine.py. Let's put all of this together. We'll go into here. This is one of my favorite steps of machine learning. Aside from getting good model results with the transfer learning model, one of my other favorite things is writing a series of experiments to see which transfer learning model works the best. So create models list. So need to create a new model. This is important. This is when we created functions. We create a new model instance per experiment so that each of our experiments starts with a model that starts from the same point. So it's a fresh version of that model rather than already being trained. So what we're going to do is create a list. I've already kind of done this. I'm talking too much instead of just coding. Number of epochs. We're going to loop through this list. We're going to loop through this models list. And finally, we're going to loop through this dictionary, create a data loaders dictionary with train data loaders equals data 10%. Now, you might be able to think of a more elegant way to set up these experiments. I'm just setting them up like this so that they're as straightforward as possible. So if you're running more, perhaps looping through dictionaries and lists isn't the best way, but for now, we're running about 8 experiments, well, exactly 8, so this will be good enough for us. So can you see what we've done here? We've got double the training time, that's one experiment. We've got double the model parameters or thereabouts. So 4 million for EfficientNet B0 and nearly 8 million for EfficientNet B2, and then double the data. So these are the various knobs that we're turning to see how they affect our model's results. So now what do we want to do? Well, we want to run code to loop through the various combinations of all of these and train our various models for 5 epochs, 10 epochs, and on train data loader 10% and train data loader 20%. So let's start to do that. I'm going to put in the magic here called time so that you can see I'm putting my money where my mouth is and that these experiments shouldn't take too long to run. So here's my GPU, you might have a different one. I've got a Tesla P100 GPU. So all of these experiments should run within a couple of minutes. Let's see if they do. So from going modular, we want to import, or .utils, we want to import the save model function. So if you recall in the going modular section, we created utils.py, and in here we have save model, which is going to save the model to file. So the reason we want to do this is because as we're running our experiments, we want to save each of them to file, each of the trained models, so that we can later on import the best performing model and further evaluate it. So if we just ran these experiments, sure, we might see which model performs the best, but if we don't save that model, well, then we've kind of lost it, right? So we come back, we want to save each model as we go, and then first things first is set the seeds, so we get reproducible results. You don't necessarily have to set the seeds all the time, but I'm just doing it so your numbers line up as close as possible to my numbers. We want to keep track of experiment numbers. We don't have to do this, but this is just I like to print out stuff while it's going to see how things are going. One of my favorite things in the world is watching machine learning model train. Now, let's start to loop through our various combinations of dictionaries and lists. So we'll start by looping through each data loader. So we'll go for data loader name. So because this is a dictionary, we're going to loop through the key and the value. So the key is the data loader name and the train data loader. Recall that all of our experiments use the same test data loader in train data loaders.items. Then we're going to loop through again, loop through each model name and create or actually we might loop through the epochs first, loop through the epochs. So for epochs in num epochs, and then we can loop through each model name and create a new model instance. This is where our functions come into play. So for model name in models, we're going to create a new model. So before we do that, actually, let's print out some info while we're here. Because we're 3 loops in, we might as well see where we're at. So let's go print out info. Want to go experiment number. This is where I'm just keeping track of what's happening. Plus equals 1, so we know how many experiments we've done. So print info experiment number. Wonderful. And then we're going to print out the number of epochs, model name, and data loader we're using. So this can be model. Model is model name. And then we'll go data loader is the data loader name. Data loader name. And then finally, the number of epochs here. Number of epochs equals epochs. Beautiful. So that's going to give us some information about what we're doing. And then we can go select and create the model. So if the model name is equal to fnetb0, we want to set the model equal to create fnetb0. Else, if the model name is something different, we want to set the model equal to create fnetb2. And we could put in some asserts and error clauses to make sure that the model name is one of these 2 models, but I'll leave that to you as an extension. What do we need to do next when we're training different models? Well, we need to set up a loss function and an optimizer for every model. So create a new loss and optimizer for every model, because as I've said, the important thing about each experiment is we want each of our models to start, or each of our experiments to start from the same starting point. Hence why we create a new model instance and a new loss and a new optimizer per experiment. Torch.optim, Atom, the params is going to be model.parameters. So we're going to optimize that. The LR equals 001. Another extension would be to vary the learning rate. You could add that to our list of experiments. Say you wanted to try a different learning rate. This could be another column over here. That's just one idea. Or even a different optimizer function. Instead of Atom, you could try stochastic gradient descent. Now let's train the target model with target data loader and track experiments. This is where our create writer function is going to come in. Create writer. So we can leverage this function. So every time we run a new experiment, we're going to create a new writer. This is why we created a function up here. So for each experiment, 1 through to 8, we want a new writer to save to a new directory. So for example, it's going to save to a new directory here for data 10% fnetb0 5 epochs, data 10% fnetb0 10 epochs, data 20% fnetb0 5 epochs, etc., etc. So let's come right back down to where we were. Oh, we're going full steam ahead. Look at us setting up this experiment code. There's undoubtedly an error here somewhere, but we'll figure it out. Maybe you've spotted it already. So model equals model, and then we're going to go train data loader. Now the reason we're calling the train function here, I just want to write note, using train rather than engine.train. So this is because what did we do before? We modified our train function in this notebook here to use the writer parameter. So we modified it there to use this writer parameter. That's what we need access to. So we're using this version of train rather than the one that's in goingmodular.goingmodular.engine. So we could save this to engine.py, but we haven't done that yet. So we will just use this. Train data loader is going to be equal to the current train data loader. So because this train function is being called within the loop here, we are using this train data loader, which is going to first be this one, and then second iteration is going to be that one. And then we'll go test data loader is always going to be the test data loader. So we can just set that to test data loader because we use the same test data loader for each experiment. Optimizer is going to be the optimizer we just created. Same thing with the loss function. Epochs is going to be epochs, which because this train function is within the epochs loop, it's going to be one of these two values. Then if we keep going, we're on a roll here. Device equals device, which is the global target device. And then here's the important point to track our experiments. We're going to leverage our create writer function. And in here, we're going to set the experiment name. Experiment name. I'm going to call the experiment name the data loader name. So for example, pizza steak sushi 20% or 10%. The model name is going to be equal to the model name we're looping through. So the model name here is going to be one of these two values. And then we can do a little bit extra here. Is going to be F. We'll go create an F string for epochs underscore epochs. So that's going to be the number of epochs and then epoch. So this will be an integer, 5 or 10 for how long we're training for, and then saving with epochs as the final tag there, just so we know what that integer means. Finally, we've just trained a model. After this, hopefully, one of our experiment models has been trained. Now what do we need to do? We need to save the model to a file. Save the model to file so we can import it later if need be. How can we do that? Well, we've got access to our save model function, which we created in Going Modular. So now let's go save file path equals F07. And here's where we're going to get creative with the file path name. So we'll go model name and then underscore. We'll go data loader name underscore epochs underscore epochs. And then if we're saving a PyTorch model, we want to make sure it has the .pth extension or .pt. So we'll use pth, and then we can call save model, and we'll set model equals to model. This is using our save model function, which is from utils.py. So it takes in model, target directory, and a model name. Beautiful. So model equals model, the trained model that we've just trained. And then we're going to go target directory equals models. And then we can go model name equals save file path. So that file path we've just created. And then we can go print. Now, I'm going to do a little trick here with strings. This is just to separate our different experiments. Oh my goodness. Look at how much code we have there to run different experiments. Now, I'm going to leave you on a cliffhanger. If you've written this all out, try it out, see if it works. But otherwise, we're going to run this together and run our series of modeling experiments in the next video. I'll see you there.